Hi everyone. So we're just going to go over quickly some basic rules with right triangles, since that's the most common type of triangle we'll be dealing with. Alright, so what a right triangle is a triangle that has a 90-degree angle in it, which then means that these two other angles then have to add up to also be 90, since all three angles have to be add up to be 180 degrees, since that's how triangles work. We have a special name for the part of the triangle, or the length of the triangle that's opposite the 90-degree angle. That's the hypotenuse. Hypotenuse? Alright, I'm not sure if that's how it's spelled, but it's pronounced hypotenuse. And I'm going to just label these legs as different values. I'm going to say that this leg here has length A, this leg here has length B, and my hypotenuse we'll say has length C. We have a formula that relates the lengths of all these three sides. That's a squared plus b squared is equal to c squared, also known as the Pythagorean theorem. Right? And we also have some trigonometric relationships here. So I'm going to assume we're going to analyze this angle here. So that letter I just wrote there is the Greek letter theta. And we're going to talk about sine, cosine, and tangent here. So if we have a right triangle and we want to know, let's say, we can set up a relationship with using these trigonometric functions. So for example, the sine function, which we abbreviate as sin, so we can take the sine of this angle, theta, that's going to be equal to the ratio of the opposite side, that angle, over the hypotenuse. So that's going to be length A over length C. We also have a relationship called the cosine function. So the cosine, cos of our angle, that is going to be our adjacent side over hypotenuse. So that's going to be B divided by A. And our final value, our final trigonometric function that we generally deal with is the tangent function. And tangent we abbreviate it as tan. So tan of our angle is going to be opposite over adjacent. So opposite of our angle over the leg that's adjacent to our angle. So that's going to be A divided by B. Along with these, we have their inverse functions. So an inverse function basically is like taking the inverse of both sides here, which allows us to solve for the angle. So if I take sine inverse of sine theta, that just gives us our angle theta, and that's going to be equal to the sine inverse of A over C, so kind of written out. So inverse functions here, the sine inverse is also known as arc sine, so the arc functions. So if we take sine inverse of A over C, that's going to give us our angle theta. So same thing with cosine. We have a cosine inverse function. You can find these on your calculator. That's going to be the cosine inverse of B over A is equal to theta. And then finally we have tangent inverse. So tangent inverse of A over B gives us our angle theta. And all these properties here can be done with other angles too, right? So we could have done it with this angle over here. And in this case, if we're solving for this angle, our sine would be opposite over hypotenuse, would be B over C. So it really depends on what angle you're analyzing. Alright, so that kind of gives us, a nice little review of how the trigonometric identities are used here. Not identities, but trigonometric functions. Now, some popular right triangles that are used, so sometimes you'll see this in a lot of multiple choice questions just because the math is pretty easy. Dealing with our Pythagorean theorem, if the base legs, so here the 90-degree angle, if one of them has a length 3 and the other one has a length 4, then the hypotenuse has to be a length 5. So that's because 3 squared plus 4 squared, so 9 plus 16 gives us 25, which is 5 squared. Right, so it's following this formula. Similarly, we have a very common triangle you also see is base legs being 6 and 8, and our hypotenuse being 10 for the same reason. Right? So those are two common values, types of triangles you'll see, ones that basically they're not trying to test you on whether you know this formula, they're trying to test you on whatever things you're doing. They're trying to help you out by giving you these values. Other common triangles you'll see is a 45, 45, 90 triangle. What that means is basically we've taken a square and divided it in half so that this angle here and this angle here are both 45 degrees. And that we do have a relationship between the sides. If this side is length x, since this is half a square, that length is also x, which makes our hypotenuse x rad 2, which we just get using the Pythagorean theorem, or you could just memorize it. Another common triangle you'll see is going to be a 30, 60, 90 triangle. So here's my 30-degree angle, there's my 60, and here's my 90. So opposite the 30-degree angle, I'm going to label that length x. So if this length of our triangle is x, that means our hypotenuse is 2x, and this base here is going to be x rad 3. So those are two common triangles, two common right triangles. I also want to mention just something that hopefully is common sense. It is common sense once you think about it, but it's just that the hypotenuse is always going to be longer than one of the legs, right? So what I basically mean by that is if we have some sort of triangle, let's say we have a leg of length, I don't know, however many centimeters that is, but some length here, right? In order to make a triangle, I have to have some amount of height. It can be very, very small, but some amount of height, and then there's my hypotenuse. That's a very wonky triangle. I probably should have used a ruler, but oh well. But in this triangle, this length here has to be shorter than the hypotenuse, just because I've gone up a little bit of height there. Right? So no matter what, our hypotenuse is always going to be the longest leg of our triangle. So just kind of something to think about when you're solving problems. It's a good way to double check your answer to see if your answer makes sense. Is always to think about that the hypotenuse should always be the longest leg of your triangle. Right? So I think that's basically all I wanted to say about these. So if you're not familiar with what I've talked about here, I do recommend you guys review it. We'll be using these quite a lot, particularly the trigonometric functions here. We'll be using those pretty much from the beginning of class, actually, at the end of Unit 1. All right?